We've seen how to create and use glyphs and specify their basic visual properties. Sometimes it's useful to be able to alter the appearance of a glyph in certain situations, for instance, when a user makes a selection or hovers over the glyphs. Let's see how the visual appearance of glyphs can be altered in these situations. Bokeh has several different tools to enable users to select points on a plot using a mouse or touch interactions. In this example, we create a figure that specifies tools equals box select, lasso select. This configures our plot to have two different kinds of selection tools. A box select tool that allows users to select points by dragging a rectangular region over the plot, and a lasso tool that allows points to be selected by drawing a free-form curve. When points are selected using one of Bokeh's selection tools, how is this fact made visually evident? By default, once a selection is made, Bokeh draws all the non-selected points with a very low transparency, or alpha value. However, it's possible to customize this behavior. To do so, we simply pass additional arguments to the glyph method. These arguments are the same visual properties we've already seen, such as fill color, except that they either have the prefix selection or non-selection. Let's take a look at the call to circle in this example. Here we specify selection color equals red. This configures the plot so that whenever a selection is active, all the selected points have a fill color of red. Note that the argument color is just a shorthand for specifying fill color and line color at the same time. Additionally, we specify non-selection fill alpha equals 0.2 and non-selection fill color equals gray. These two arguments configure the plot so that whenever there is a selection made, all the non-selected points will be shaded gray with a high transparency. The two plots here show the effects before and after a selection. Before the selection, all the circles are drawn with a default appearance. After a selection is made with the box select tool, the unselected points outside the box are gray and transparent, and the selected points inside the box are all shaded red. It's also possible to add a hover tool to Bokeh plots. The hover tool can be used to drive hover tooltips, which we'll see later, but can also be used to inform changes to the visual appearance of glyphs. The hover tool is a bit more sophisticated. Let's first take a look at how it's added in this example. First, we import hover tool from Bokeh.models. We create a hover tool instance called hover by calling the hover tool initializer. We pass in the arguments tooltips equals none and mode equals hline. This configures the hover tool not to display any tooltips and to use a horizontal line under the current mouse position to perform hover inspections. We add this tool as well as a crosshair tool to our plot by passing a list containing the hover tool and the string name crosshair to the tool's argument to figure. Having added our hover tool, we can now also specify a hover policy. This is very similar to how selection policies are specified. Instead of property names prefixed with selection or non-selection, we can add property names prefixed with hover. In this example, we have added hover color equals red to our call to circle. Accordingly, whenever a circle is hovered over, it is drawn as red. All other circles are drawn in their normal fashion. Finally, let's look at one more important way to customize visual appearance that has to do with shading groups of data differently. Let's consider the iris data, which has data for 3 different species of flower. What if we want to shade each species differently? We could make 3 separate calls to circle, each with a subset of the data and a different single color, or we could make a single call to circle with a column of colors that we compute by hand based on the species. But there's often a better way, which is to configure the color properties with a color mapper that refers to some other column that should already be in the data. Let's take a closer look. First, we need to create a categorical color mapper. In this example, we want to import it from Bokeh.models. The color mapper needs to be configured with 2 arguments. The first is a list of the values to map. In this case, it's the 3 species names from the data, Setosa, Virginica, and Versicolor. Next, we also have to supply a palette, which is just a list of colors. We provide an explicit palette, red, green, blue, but there are many built-in palettes available in the Bokeh.palettes module that can be used as well. Finally, we configure the glyph to use this mapper. This is done in a slightly different way than we have seen so far. For the color argument, we pass a dictionary. This dictionary has a key for field, with the value being the name of the column to map. In this case, it's the column name species. It also has a key for transform, which is the color map for the associated value. By passing this special dictionary, the color mapping now happens in the browser automatically. Looking at the plot here, we can see that the points are shaded according to their species value and the color map we provided. In Chapter 1, we learned how to create basic plots using the Bokeh.plotting interface. We saw that it's possible to use a variety of data types as inputs, and that it's possible to customize the appearance of glyphs for different use cases. Sometimes we might want to create more than one plot at a time. We also might want to link interactions across plots or add annotations to our plots. Let's take a look at each of these topics. Although we haven't gotten to them yet in this course, it should be mentioned that Bokeh also supports all sorts of user interface controls such as sliders and menus. These controls can be arranged visually within a document together with plots to make a rich interactive application. We will talk more about controls later in the course. For now, we will learn how to use Bokeh's various layout functions with plots. What are the kinds of layouts Bokeh supports? The simplest kind of layouts involves putting elements such as plots in rows or columns. These layouts can also be nested to build up more sophisticated layouts. Bokeh also supports gridded and tabbed layouts. We will take a look at these in the next section. First, let's dive into rows and columns. Our first example demonstrates how to place 3 plots in a horizontal row. First, we import the row function from the Bokeh.layouts module. Then we pass all the elements as arguments to row in the order that we would like them to appear from left to right. In this example, we pass 3 plots P1, P2, and P3 to row. You can see in the resulting output that 3 plots P1, P2, and P3 are arranged visually in a horizontal row from left to right. Later, we will see how controls such as sliders can be added to layouts as well. Next, we turn to columns. This is just as simple as using row. This time we import the column function from Bokeh.layouts. The elements we pass will be arranged visually in a vertical column from top to bottom. That's exactly what we see here with the 3 plots P1, P2, and P3 arranged from top to bottom. The last thing to mention is that rows and columns can be nested. It is possible to pass a column as an argument to row or vice versa. In this example, we first create a column with plots P1 and P2. Then we make a row comprised of the column and P3. The visual output should not be surprising. It's a column and a plot next to one another horizontally. In addition to rows and columns, Bokeh also supports gridded and tabbed layouts. Let's take a look at these. To use gridded layouts of plots, first import gridplot from Bokeh.layouts. The argument to gridplot is slightly more involved. We pass a list of lists where each inner list represents one row of plots we'd like to display. Then all the rows are used to arrange a grid. It's important to note that all the inner lists for the grid rows should be the same length. If we want any empty space in our grid, we can plug in the Python value none as a placeholder. Finally, it's important to note that the grid plot has an additional functionality. It gathers all the individual toolbars into one single toolbar for the entire grid plot. Then, for instance, if you have an active pan tool, the pan tool will be active on all the subplots. The location of this toolbar can be specified with the toolbar location argument, which can be set to above, below, left, or right. Or, if no toolbar is desired, it can be set to none, as we have done here. Looking at the output, we can see the correspondence with the list passed to gridplot. A row with an empty space, then plot P1, and then a second row with the plots P2 and P3. It's also possible to create tabbed layouts with Bokeh. This is slightly more involved, because there are 2 steps. First, a panel must be made for each tab, then the tabs must be collected into a tabs object. Let's take a closer look. First, from Bokeh.models, we import panel and tabs. Next, we create a panel for every tab we want to have. This is done by calling panel with 2 arguments. The first argument is the child argument, which should have the content for the tab. This can be a plot or another layout. We can put in plots or controls or rows and columns of plots and controls. The second argument will be a title for the tab, which is what is displayed to users. To actually create the final layout that we want to show, we call tabs with a list of the panels as the tabs parameter. Here we see the output from the previous code. 2 tabs titled first and second, and the first tab has a row of P1 and P2.